Hello friends, myself Aradi Mahajan presenting my one more video on Leibnitz Theorem. Let us solve the problem. If y is equal to e raised to tan inverse of x, then prove that two results. Number one, 1 plus x square into y2 plus 2x minus 1 into y1 is equals to 0. And after getting this result, second result, 1 plus x square into yn plus 2 plus 2 times n plus 1 into x minus 1 into yn plus 1 plus n in bracket n plus 1 yn. And therefore to prove this result, if you observe this second result, there are the terms n plus 2, yn plus 2, yn plus 1 and yn. These are the order of derivatives in decreasing order, and whenever we are having such type of term, it becomes a problem of Leibniz theorem. And therefore here given is y is equal to e raised to tan inverse of x, and to obtain result number 1 we have to differentiate that term twice with respect to x, then getting the result number 1. And after this result, to obtain second result, we have to apply a Leibniz theorem. And therefore watch the video up to end. Differentiating given with respect to x as it is function of x, we get the first derivative as y1. Differentiation of e raised to tan inverse x is e raised to tan inverse of x, and as it is function of function, applying chain rule, differentiation of tan inverse of x is 1 upon 1 plus x square. Then cross multiplying by this to left hand side, we get 1 plus x square into y1 is equal to e raised to tan inverse of x. But e raised to tan inverse of x is nothing but y. Therefore, once again rewriting this term, we get 1 plus x square into y1, and transferring this, we get minus y is equals to 0. Equation number 1 we call it. And then differentiating is again with respect to x, again differentiating. With respect to x, here it is product of two terms, therefore applying product rule, UV rule. First term 1 plus x square, differentiation of y1, we get that term as y2, plus second term as y1, and differentiation of 1 plus x square with respect to x, its differentiation is 2x, minus differentiation of y as y1, and that is equals to 0. And therefore rewriting it, we get 1 plus x square into y2, only one term, and there are two terms of y1, combining it we get 2x minus 1 into y1. When we take y1 common from this, we get 2x minus 1 into y1 is equals to 0. Required result number first, we call this as equation 2. We have that term 1 plus x square into y2 plus 2x minus 1 into y1 is equals to 0. Here the half part is completed, and after getting this result, we want the term yn plus 2, and to obtain that term yn plus 2, we have to differentiate this n times. Means it is nth derivative of this equation number 2 to get this equation, required equation or required result number 2. And therefore next differentiating n times by applying Leibniz theorem. We get. Therefore I will perform in a single step only. In the previous example, I have discussed by finding nth derivative of the first term, nth derivative of second, and then I have added. Here I will perform in one step. Using Leibnitz theorem, we state like this: nth derivative of the product uv, both are functions of x. Then we have nth derivative of u into v plus n into n minus first derivative of u into v1 plus n minus 1 by 2 factorial n minus second derivative of u into v2 plus so on u into vn. Here the derivative of u is in decreasing order: nth, n minus first, n minus second, and so on. Last one is that function u, and derivative of v is in increasing order: v, first derivative, second, third, like this, nth derivative. And as already I have stated, consider v such that whose finite derivatives will exist. Therefore, here in this term 1 plus x square into y2, we have to consider 1 plus x square as v and y2 as u. And therefore, applying Leibniz theorem for the first term, nth derivative of y2 we get as yn plus 2 into v. V means 1 plus x square. Next, n into un minus 1. Decrease the suffix by 1. We get next term as yn plus 1 into v1 means the first derivative of this term. The first derivative of that 1 plus x square is 2x. Next one plus n minus 1 by 2 factorial. Un minus 2 means again decreasing this suffix by 1. We get next derivative as yn. Our differentiation of 2x is 2, and as we get here constant, next derivative becomes 0. Therefore, this is the nth derivative of the first term 1 plus x square into y2 by applying Leibniz theorem. Similarly, we differentiate this second term using Leibniz theorem n times. We get the first term as, here also we consider that 2x minus 1 as v and the remaining term y1 as u. Therefore, nth derivative of y1 we get as yn plus 1 into v. V is here 2x minus 1 plus next one is n into un minus 1 means n, decrease it by 1 suffix by 1, we get yn. Differentiation of this term with respect to x, it is 2. Next one is 0 as we get the constant term, and that is equals to 0. Simplifying it by combining the similar terms in one bracket, we have only one term of 1 plus x square into yn plus 2. Therefore, that term I will keep as it is, 1 plus x square into yn plus 2. Then 1 and 2 terms of yn plus 1, 2nx remaining term, and here it is plus 2x minus 1 into yn plus 1, and 2 terms of yn. We can divide, cancel that 2 and 2 factorial, we get only n. Remaining is n minus 1, and here it is 2. And that is equals to 0. And then simplifying it, we get the required result. First term is 1 plus x square into yn plus 2 Yes, we get the first term. Then from these two terms, I can take 2x common. Remaining terms is here n, and here it is 1. Therefore, 2x into n plus 1, and this minus 1 as it is, no change, and into yn plus 1 plus outer n as it is, n plus 2 minus 1, remaining is 2 minus 1, we get plus 1. Therefore, it is n into n plus 1 into yn is equals to 0, the required third term. Hence, we get the required result number 2, hence proved. Therefore, 1 plus x square into yn plus 2s, we are getting it, into plus 2 into n plus 1 into x, and minus 1 into yn plus 1 plus n plus 1 into yn is equals to 0. Therefore, in two parts, we are able to get the required result. One more I will discuss in my next video. If you like my video, please share it, as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you.